For this project, we wanted to test Newton's third law, which indicates that for every action, we have a reaction. In order to prove this law, we built a water rocket that is a chamber filled with water and air force inside with a pump. The objective of this project is to find the relationship between the amount of water used and the pressure applied to the rocket in order to know the maximum height it can reach.
Our hypothesis is that by changing the mass, it will change the height of the rocket. The bottle has to have a certain amount of water because if it's too light or too heavy, the rocket won't reach its maximum height. Formally stated, Newton's third law is for every action there is an equal and opposite reaction. The statement means that in every reaction there is a pair of forces acting on the two interacting objects.
Other concept we are going to work with is pressure, which is defined to be the amount of force exerted per area. The formula is P equals F, which is a force, over A, which is the area it acts on. On our experiment, there are three main forces: thrust, drag, and weight. The thrust is generated when the water is expelled from the rocket through the nozzle at the bottom of the bottle. The drag force exists because of the friction caused by air molecules alongside the rocket. Variance in the shape of the rocket will affect the amount of drag. However, because we won't test this factor, we will need to make sure this remains as constant as possible.
Lastly, weight is just the mass of the rocket multiplied by gravity. In order for the rocket to launch, the thrust force must be stronger than its weight. To evaluate the maximum height a rocket can reach, we need to use a formula that describes the vertical throw. This formula is position in time equals 1/2 times acceleration times time to the square plus initial velocity times time plus initial position in y. With a marker, draw in a bottle 3 lines. The first one around the nozzle, the second one above the label of the bottle, the third one around the base. Now, cut on the drawn lines. For the ailerons, mark the ailerons measurements on the cardboard 4 times. Then, cut on the drawn lines. Draw a line with 1 cm from the base and divide the segment into 4 equal parts. Now, cut on the lines. Make 4 lines of 10 cm of length around the cut middle part of the bottle, with the exact same distance of separation between one another, to posteriorly cut on the lines and introduce the aileron stabs into these openings. Reinforce with insulation tape on the inside of the rocket. Now take the other bottle. Make a small ball with the clay and stretch it on the base of the bottle. Place the cut middle part into the upper part of the complete bottle. On the clay, put the plastic grocery sack to cushion the fall. Replace the cut upper part on the complete bottle. Reinforce the union of the bottles with insulation tape. Fill 1/3 of the bottle with water. Introduce a cork in the bottle's nozzle. Finally, introduce the pivot of the bicycle pump inside of the cork and place the rocket on the base. At first, we thought this project was not going to work.
¿Qué estás haciendo? ¡Más, Melissa! Es que aparte solo está haciendo burbuja.
But then we changed the amount of force exerted with the pump, and we've got our results.
In conclusion, after several attempts, we managed to obtain the expected results and prove our hypothesis. The bottle needs to have approximately 600 milliliters of water so the rocket can reach its maximum height. We could also notice that if we filled the bottle with too much water, the rocket was heavier and it didn't leave enough space for the air to act upon the water. Although, if the bottle is filled with less water, it won't have enough force to take off.